Yeah, I'm here.
All right. Good morning.
Good morning. So, thank you everyone for joining me. My name is Scott Schmidt. I'm the senior analyst in the operator training and certification unit for drinking water. This is a course that I think this is only the second time that this has actually been ran, believe it or not. So it's a very short course, geared at giving you a very it'll give you a handle on an introduction to fluoridation and chlorination over the next 3 days. Today we'll be dealing with math basics because there's some basic concepts of math that you need to understand first in order to do a chlorination question. So at any time, do try to ask questions if you have any. That's kind of, I guess, the introduction that I have for things. And then know that any of you taking these for CECs, we will try to get the lists back as soon as we can from Jim's group and get them entered hopefully by next week because I know some of you are taking this for CECs because you expire on the 15th coming up. Just know that if you have postmarked or submitted your application online for renewal, you will not be held as late if these are the CECs that you need, okay? Because we do backdate them. We do backdate licenses. As long as your application is here before the 15th or postmarked by the 15th, you'll be okay with that, okay? I just want to make that aware because I do have a strong feeling that a good at least half of you are here for the continuing education credits for your license to renew on the 15th. So I guess with that being said, I am good and ready to roll, Jim.
All right, Scott, you should be able to share your screen over mine now.
All right. So here we have let's see your screen. Okay. Here is the very first section that we're going to be dealing with. So like I said, the reason that this is broken into 3 2-hour sessions, one to go over the rule basic math, another to deal with chlorination, and then another to deal with fluoridation. We will have a break because I don't expect anyone to sit here for 2 hours straight and enjoy math. All right. Some of you, looking at the participant list, some of you I do recognize your names. Others, welcome. You know, this is, I know you don't see me per se, but you do hear my voice. I will be around teaching a lot of the 3 day short courses and such that we have that we're doing in conjunction with Jim's group, planning everything. So if you haven't heard yet, yes, the 3 day short courses for the state this spring are back in person. So look for our training calendar on that. Registration for those will be opening soon. I do believe limited treatment's already open, but distribution and water treatment will be coming soon. Okay. So one thing on our website, and just so you know, this isn't something that we hide from you. This is known as the math formula sheet. I will be referencing some of these conversion factors today at some point. You can get it off our website at michigan.gov/EGLE or Eagle operator training, all one word. Okay. Um, so this is available on every single test. This is available on our website under many different things. It's under the exam applications page. It's under the main page under certifications. It's available in like 3 different locations on our website. So this is here. It's not a secret. This is given to every single examinee in the exam books. So if you're taking an exam in May, do submit your exam application by March 1st. Okay. So March 1st is the application deadline for May 1st exams. But I won't like keep showing you this because I have all these, been doing this a long time. So I have these memorized, but that's where you can find these. Um, and as far as calculators goes, I don't have my normal one. I'll have to bring it tomorrow, but this is an acceptable calculator for the certification exams. The typical one that I use is the TI 30X, and then it's 2S. This is the one I typically use. Um, And the reason that I like either this one or this one I prefer the most, I'll bring it tomorrow. I didn't have it with me today, is that these are multi-line calculators, meaning you can see what you typed in and you can see your answer. You can see everything you type in. So that's why I prefer multi-line calculators, because if you have just a TI-30, you don't get to see what you have, all right? As far as that goes. Non-programmable calculators or programmables are not allowed. No web browser, yes. Have you already had the poll question? Looks like lots of stuff. Yeah, those are gonna be left to Jim. Okay. All right. So with that being said, let's go ahead and get started. So the very first thing to understand with what we got going on here is talking about the rules of fractions, okay? As far as the rules of fractions go, there are three main rules with fractions, and with those rules, they help us with understanding how the rest of the math is going to go. And no, there are other things as far as fractions and math go, like least common denominator and such, but that's not what I'm referring to. Okay, so the very first rule of fractions here is knowing that you have the numerator over the denominator, or like I like to say is the top number. There we go. The top number divided by the bottom number. So the top is always going to be divided by the bottom. And this is going to give you a decimal, all right? So the first rule of fractions is knowing what a fraction is. It is top divided by the bottom. And the thing is this bottom number here actually represents the whole number of something, okay? Because when we think of like 1/2 here, think about like a glass of water. When I say it's half, you think, well, it's half full, right? 1/2, everyone assumes that it's 1/2. The thing about it is what it's really saying is you have one of the two. That's really what a fraction is. The 2 represents whatever the whole thing is. Does that make sense? Because what happens if it's a 125-gallon drum? Well, the bottom number is going to be the 125 gallons because it's the whole. All right. So really a fraction is saying you have one of the two. All right. So it would be similar to saying if I have two phones, if I give you one of them, you have one of the two. Does that make sense? So the bottom number is the whole thing, and the top would be the part of. So it's part of the whole thing. So this could be in reference to anything. So you could start to think like, well, my truck has a 22.4-gallon gas tank in it, right? And if I have, let's say, 10 gallons in it over the 22.4, do you have part of the whole? This is really what a fraction is understanding that the bottom is the whole thing in reference to whatever you're referring to. Be 125 gallons. It could be the 500,000 gallon storage tank that you have in your water system or anything along those lines. But also keeping in mind that it's always the top divided by the bottom is going to give you a decimal. So one thing to note here is always convert fractions to decimals, okay? And I do believe I talk about that on the next page, but always convert fractions to decimals, all right? Because if you're going to do the math with these, if you do not convert it to a decimal, good luck with trying to do it, okay? So whenever you see a fraction, you have my permission to always convert it to a decimal. There are going to be a few always rules that I talk about, which is something to always do. It's kind of like a rule of thumb. It helps with doing the math. Like if you incorporate, well, I always do this or I always do this when I see certain things, it's going to make your life easier. Rule number 2 is anything over itself or anything divided by itself equals 1. So 5/5 equals 1, 2/2 equals 1. The thing about it is it does not pertain to just numbers. So meter over meter equals 1 and feet over feet equals 1. Well, how about inch over inch? This is not a trick question. Inch over inch would equal 1. essentially what really happens here, if the number or unit is the same on the top as it is on the bottom, they will cancel and equal 1, okay? If it's the same on the top and bottom, they cancel and equal 1. Does that make sense? So inch and inch, since they're on top and bottom, cancel out and equal 1. Now, we have rule number 3. Rule number 3 is saying that anything over 1 is itself. And we're getting a lot of... Are you watching the Q&A there, Jim? Oh, you're working on it right now. Okay.
Yeah, Scott, I'm watching Q&A, no problem.
Okay. It's like, man, it's the number's just going up and up. All right.
Just a few people asking about the poll question. We're figuring it out.
Right. Yeah, and I wouldn't be surprised if something with the Chromebook that it doesn't support it, to be honest. Chromebooks, that's the one thing. They're really nice, but they also don't support a lot of stuff. So anyway, rule 3. Rule 3 of fractions is anything divided by 1 is itself. Right? So 7 divided by 1 is 7. 11 divided by 1 is 11. 6 feet divided by 1 is 6 feet. So really, what about this? My first question is saying, how about number 9? My first question is number 9 a fraction to you? Well, it doesn't look like it, but it could be, couldn't it? What happens if I put a 9 over 1? What's that equal? Well, that's going to equal 9, right? So really what this is saying is that any number can be put over 1, right? Any number can be put over 1. So 9 over 1, 177 over 1, it doesn't matter. They can all be put over 1 because when divided by 1, it equals 177. It doesn't change what the number itself is, okay? So number 2 and number 3, especially when we get to unit conversions, are going to be really important. It's not to say that always converting here is not important. It is always converting fractions to decimals, but I promise these are going to be real good. Okay, so here at the bottom, on the page 1 and the top of page 2, there are some questions that I'm going to give you all like 3 minutes to do on your own, and then we'll go over them, all right? These aren't trick questions. They are that easy. They are that straightforward, all right? So I'll give everyone like 3 minutes to do these, and then we'll move on. All right, it has been 3 minutes. Okay, so I'll do the easy ones first. 7 divided by 7 would be what? 1. 3,911 divided by 3,911 is 1. And then 22 inches over a question mark equals, well, this is 1. And same with this one, right? This is just to get you in the habit of understanding how the rules work, all right? But remember here with these, this is, if we look at what it is 11 is the whole thing. So it could be 11 gallons, 11 inches, anything, right? But what it is we're saying we have 3 of the 11, which is top divided by the bottom number. So 3 divided by the 11 is going to give us 0.27. Okay, so yes, I did get a big, long, repeating number, okay? One thing I often get is, how do I round these numbers? How do I round them, right? So let's do this one real quick too, and then I will talk about rounding, all right? So 7 divided by 21 gives me 0.33, another repeating forever number. So I round to 2 decimal places, and you can't be a good mathematician unless you always have some sort of exception. All right. I'm going to just give you a heads up. Many of you, maybe some of you are scientists, maybe some of you have taken science classes in college and so on and so forth. But one thing you start to come to learn as being a scientist or math person is there's always an exception to some rule, right? Chemistry's full of them, biology's kind of got some of them too, and math's got a ton of them where they're always saying, well, there's always an exception to the rule. It's in rare instances, but there's always an exception. So I rounded 2 decimal places. So what that means is 1, 2. That means 2 places after a decimal, like here, 0.33 and 0.27. All right. And I round to 3 places only on big M pounds and million gallons. Okay. We will see these today, but million pounds and million gallons. And when we get to an example, especially with chlorination tomorrow, maybe today, but more likely tomorrow, I will show you why we go to 3 places on these. Okay. So as a quick reminder, 1.227, what would we round that to? Well, we're going to 2 decimals. So I'm going to keep that. And you look at this one, remember 5 and up, you round up, 4 and down, we would just leave it off. So here we'll do 1.23. So what I mean by leave it off is we'll do this again like this, 1.224. Well, being that this is 4 and under, we just leave it as 1.22. Okay. Now here's the other kicker. Maybe some of you have taken the test, maybe some of you have not. On the tests, we do not put 1.22 and 1.23 and say, which one is it? Okay, we do not go A, B, C, and D and go 1.22 and 1.23. So you got to take your pick, right? We do not do that on the test. And matter of fact, I will tell you that if we do one that is too close, we just did one this time around, which I can tell you it was like A, B, C, D, whatever. Well, this answer was 0.4 and this one was 0.6. Okay. Well, if you did the math to the question, you got 0.51. Like if you did it without rounding. So that falls almost dead in center of those two, doesn't it? You know what we did? We gave everyone credit for this question and this one. So after the test, we caught it. We gave everyone credit. Okay. So if we do put them on the test, depending, like if you round and it's like kind of in the middle, leave us a comment on the question. We will look at it. And if it is true or we caught it, we will give people credit for everyone who takes the test, not just the people who said something about it. Okay. So I just want to give you a heads up. We absolutely try our best to not ever do this or this on a test, but we are human just like everybody else. All right. So here, 49 over 121. So 49 divided by 121 gives me 0.40. Okay, this would be 1 because these cancel out, and 8.4 gallons over 1 equals 8.4 gallons. All right. So the next thing we're going to talk about is percents, and think of percentages as part per the whole thing. Okay, because if we start to think about it, a lot of people like to think percentage as parts of the 100. But the thing about it is nothing we deal with is ever a perfect 100, is it? I don't have 100 gallons of water. I don't have 100 bolts. I only have 100 meters, right? Or 100 hydrants. I don't have a perfect 100 of anything in my water system. So that's why percentage, I like to think of percentage as parts per the whole thing, because it could be anything at that point. Part of the whole, doesn't matter what you're talking about. So down here, we have percentages and we have decimals, okay? Yes, there could be related to fractions, but that's a waste of time. Okay, so I have 11% on this side, and if I want to convert it to a decimal, how do I do that? Well, I want to go 2 places to the left, all right? So we're going to go 1, 2 like this, and I'm going to get 0.11 here on this side, all right? And if you do that here, you go, well, I got 0.16. So I'm going 2 places to the left. So there's a couple things here that we need to talk about, though. So first off, what happens if I have, we'll say 9%? Well, I don't see a decimal there, do you? Well, the decimal's assumed to be right here behind it. So you go 1, 2 places to the left, and that leaves a blank. So one thing to note is that any blank spot, well, what do we do there? We should fill it with a 0. So the decimals of 9% will be 0.09. Any blank spot should be filled with a 0. All right, that's something to note. And one other thing to note, what did we always do when we have a fraction? Always convert percents to decimals, okay? Before you do the math with anything, whenever you see a percent, you should always convert it to a decimal, all right? And the reason for that is if you do not do that, it can cause funky numbers. And I will tell you that answer, if you forget to convert a percent to a decimal like you should have, and say you got to multiply it by something, there's a very strong chance that you will see that answer on a test in an ABCD just because you didn't do it right. So without converting a percent to a decimal, your answer is going to be 10 times, 100 times bigger than it should be. So it wouldn't make any sense if you think about it logically, but I get it. We have test anxiety. Sometimes we forget to do things, so on and so forth. If you ask my wife, I forget to take the trash out all the time. It's always overflowing. So, we're human. We do forget to do stuff. So sometimes we need to go decimals to percents, not very often. But if you need to know, if we went 2 places to the left here, what do you think we do here? Well, you're going to go 2 places to the right. Okay. So that's what we do here for decimals and percents. Just so you know, if you haven't yet realized, I don't read the page to you. That where text is there for you in the future. If you're going through this on your own, you're not watching recording and it's just me, or so on and so forth. So I won't read this to you, but I'm telling you what you need to know. All right. So here on the next page, it starts off and says, what is 25% of 90? So the very first thing you need to do when you see a percent is what? First thing we do is convert it to a decimal. Okay. So now when you start to think of a question like this, if you ever ask yourself that it's like a percent of question, just like this one where it says, what is 25% of 90? Well, if you read a question to yourself and it's not this straightforward, but it's saying percent of a whole of something, all you need to do is multiply by. Percent of means multiply by. So you go 0.25 and you multiply by whatever the whole thing is. And when we do this, we're going to get 22.5. And no, I would not round that to 23. 2 decimal places, it's okay. So 22.5. Does that make sense? Now, I will tell you when you're talking about, there are a few certain circumstances that you do always round up. And that would be like a section of a pipe, right? Because if, say, your pipe comes in 18 or 20-foot sections, I think it's usually 20-footers, and you only need 12 foot, and you're going to find someone that's going to sell you just 12 foot of pipe. No, you're going to have to round up to one section of pipe, right? Same with filters. If you're doing a filter question and you determine you need 2.2, well, you just don't get 0.2 filters anywhere. And a lot of times you can't increase your filtration rates. So you would round up. And then another one is like people. If you're doing a population calculation, a lot of times you're going to round up for people also, regardless of what the answer is. You'll round to the next whole number. And the reason for that is a lot of times having more people means more funding, right? So if you project you're going to have one more extra person versus one less, you might get that extra, if it's a school, I think the per pupil is like 11 grand now or something. So that could be $11,000 that, because a lot of that stuff's based on projections of where you think the school's growing. So pipes, people, and filters you round up, just FYI, all right? So I guess we could write that down. Round up, filters, pipe, and people. Man, my handwriting is not great today, sorry. Round up on filters, pipes, and people, all right? So like, depending if this actually had some context with some numbers or what we're talking about, maybe we would round up. But if it's just numbers, we aren't going to. Okay. What is 32% of 612? So the very first thing to do is convert 32 to a decimal and then go ahead and divide it by, or multiply by 612. All right. So when we do that, we're going to get 195.84. We are not going to round that up. We're going to leave it as 2 decimals, okay? Now the next one, a 500-gallon tank contains 320 gallons. What percent of the tank is full? So the very first thing is here is, what is the whole thing? The very first rule of fractions is what I taught you how to do this one. The whole thing is 500. Well, in a fraction, where does that go? On the bottom. And the part of goes where? Up top. Remember, equals, this is part of over the whole. 320 over 500. That also means what? 320 divided by 500. And just so you know it's written down here, but I do these on my calculator as I go through these with you all, just because it gets muscle memory, right? Muscle memory, especially in math, is a big thing. Writing it down and doing it helps with remembering it. So I got 0.64. Well, that's not a percent. Remember how to get a decimal to a percent? 1, 2 places to the right. So 64%. All right. Okay. On page 4, I guess just page 4, I want you all to go ahead and try these out. I will give you, we'll say like 4 minutes to do page 4, and then we'll go over them together, okay? See you soon. All right, I think it's been about 4 minutes. I don't know. I was answering a couple emails and stuff real quick. So, all right. So write the decimal equivalent of the following percentages here. All right. So what I need to do is convert these percents to a decimal. So the first thing is to wait. Well, there's a decimal here. So I go 1, 2 places to the left, which makes this 0.29, right? 7% is a decimal. Remember, 1, 2. Fill any blanks with a 0. So 0.07 here. The next one, 252%. So what is this as a decimal? 1, 2, right? Well, this is 2.52. The next one's somewhat of a trick question, but not really. Half of 4%. What's half of 4? 2. So 2% as a decimal was 1. So 0.02, right? When we move it over to the 2 places to the left. The next is write the following decimals in percentages. So here is 2 places to the right. 1, 2, 40%. 1, 2, 27%. 1, 2. So this is 0.9% because it's right here. And then 918%. Are you asking yourself, how could you get 918%? That doesn't make any sense. Well, ask the person in Grand Blanc who won the $842 million Powerball the other day, right? That ticket cost that person $2, didn't it? Well, they won 800 million. So think about it. If you only won $2 back, well, you made 100%. You got your money back, right? But when you win 842 million, that $2 is like 12,000% or something ridiculous. I'd have to do the math, but yeah, it's something ridiculous like that. Yeah, it's geez, oh Pete, that's a big number. 2 places. 4,210,000% growth on that money. Don't we wish we all had that luck? So anyway, a chemical solution tank with 150-gallon capacity is filled to the 70% mark. Is this a percent of question? It is. It's 70% of 150 gallons. So what do we got to do? We got to convert this to a decimal, so 0.7, and then we times it by the 150, which is going to give me 105 gallons. All right. A water treatment plant with a capacity of 350,000 gallons per day is operating at 45% capacity. How much water is the plant processing? So is this percent of? It is. So it's going to be 1, 2 here, give me 0.45. Excuse me, multiply by 350,000 gallons per day. And I think it's 157,500, but I don't, I got to do this. I have a calculator for a reason. Yep. 157,500 gallons. Okay. So these are percent of questions also. They're just a little bit different, aren't they? So this is everything we've learned so far with the percents and decimals. All right, the next one. So I'm not gonna lie. We do areas of volume stuff today too, but this is the section that we will spend majority of the time on here, the next little bit for the remainder of the class. As unit conversions is something that everyone struggles with, and I will tell you that it takes practice. I don't expect anyone to be perfect at, especially after only doing this for 2 hours, right? I don't expect you to be perfect at this, but unit conversions is something that is very important. Excuse me, because there's not a one part of math in drinking water that doesn't involve some sort of unit conversion. All right. Water went down the wrong pipe. Because even if you are dealing with chemistry, there is a unit conversions to the chemistry. It's called stoichiometry. So, and the thing about it is, I hate to tell you this, but you do unit conversions already. Some of you already know unit conversions, and some of you do it as part of your job, or even not in daily life. So think about daily life here. Well, tell me when I do unit conversions just in my daily life. Well, are you ever driving your car or truck or van or whatever you drive? You're driving your vehicle. You look at the gas gauge. Then you look as the gas station you drive by, which in Lansing it went up to 2.99 over from 2.58 last night. So it went up to 2.99 a gallon. But you look at your gauge. You look at the price. And most of the time, I'm not saying you're going to get it to the exact penny, but you can usually you look at it and go, it's a half. Well, it's going to be about $30 to fill my gas tank, right? Something like that. That is a unit conversion. You're taking a gallon's reading and converting it to dollars because you know, right? You know your vehicle, you know roughly at the gauges and stuff from know-how. That's a unit conversion. I know that seems simple, but it's true, right? Or, you're getting 6 donuts at the gas station or the local bakery, whatever. Well, you go, well, that's a half a dozen. Well, you just converted 6 donuts to dozens, didn't you? So you do unit conversions, you just don't realize it or think about it, all right? So the very first thing though is learning how to do unit conversions, all right? What a unit conversion is it's first off is dealing with what we call ratios, which is a fancy word for saying two different numbers equal each other, okay? And we write them as fractions. Okay, so what I'm trying to get at here is let's think of like 1 foot equals 12 inches, right? We can all agree with that. And just so you know, I'm not gonna, like I said, I don't need to use this, but all the conversion factors that you're ever going to need for any test is right here. The only ones we don't give you are like how many minutes are in an hour, So like if you had to say how many minutes are in an hour, it's gonna be 60 minutes equals 1 hour, right? My 8-year-old at home can tell you this. So, and I assume your kids probably can too. So, unless they're really young, obviously. But so you take a unit conversion. This is a conversion factor here, okay? So with a conversion factor, the very first thing about understanding with a conversion factor, these are two different numbers that equal each other, aren't they? 60 and 1 are not the same number. So that's what I meant by ratio. The other thing to understand here is that these can be written as fractions, okay? As long as they equal each other, like 1 foot equals 12 inches, 60 minutes equals an hour, they can be written as a fraction like this. Or you could even do 60 minutes over 1 hour. Okay. So just knowing that a conversion factor could be written as a fraction is the first step in understanding a conversion factor. And a lot of times I get asked, well, how can it do that? Well, let me times them by each other and I'll show you something. Remember the second rule of fractions says if it's the same on the top as it is on the bottom, what happens to it? Cancels out. If it's the same on the bottom as it is on the top, it cancels out. So if I were to multiply those two conversion factors together, they equal 1. Well, that's in math, just FYI, that's what you want. You want it to equal 1. If it equals 1, that's good. That means we can write these as fractions, okay? So the very first example here says we're taking 15 feet and we want to convert it to inches, okay? So I'm starting with 15 feet. So you write what you start with first. That's the very first thing in unit conversions. The second step, back up. We're still on first step. Is this a fraction? First off, is 15 feet a fraction? Well, no, it's not, but can it be? That's the first thing to ask yourself. Can it be? Well, yeah, it can be over 1, right? 15 feet can be over 1. So now it's a fraction, sort of, because 15 feet divided by 1 is still 15 feet. So the next thing here is where are my feet? Are they in the top or are they in the bottom of a fraction? Well, they're in the top here. Okay, good. Just now we're moving on to step 2. Well, and step 2 is to identify a conversion factor. So think about, if it's something involving water and it's something you don't know yet, you use a conversion sheet, right? But you can see like the conversion factor I need for this isn't even on here. And that's because we assume you know that, right? It's almost a universal constant, at least in the US, to know how many inches are in a foot. So I know that 1 foot equals 12 inches, correct? Like this? Well, just like this, we talked about can be written as a fraction. 1 foot can be over 12 inches or 12 inches over 1 foot, correct? Remember, a conversion factor is converting from what you want to what you need to get. So like feet to inches. So feet to inches makes sense. And then we need to arrange it so that feet cancel out. So here, my feet are on the top, correct? So where do my feet have to be to cancel? Well, they have to be here. And if I look at my conversion factor, so in this box here, look at for my conversion factor. If feet have to be on the bottom, which one of these two would you choose? Well, foot goes here. Now, the only thing that can ever go with 1 foot is what 1 foot equals. So what goes above the 1 foot is what it equals, which would be 1 foot equals 12 inches. Nothing else can ever go in that box. You do not write 15 feet in there. You write what you start with once, and then with your conversion factors, each time you move, it's just what it equals. So feet are on the bottom, so 1 foot is on the bottom, 12 inches has to be up top because that's what it equals. Now to do the math, you cancel that out, and you multiply everything on the top this way and everything on the bottom this way. So 15, so kind of think of it like this. What's that look like? Well, that sure looks like 15 times 12 to me, which is 36, 180. Wait, yeah, 180. Well, and then if you look at the bottom, I got 1 times 1. Well, what's 1 times 1 equal? It equals 1. So 15 feet is 180 inches, I think. Let's probably check that. Yeah, okay. So yeah, I can do some things in my head, but it has been like 4 months since I've taught this. So 15 times 12 equals 180 inches. All right. So here on this next one, 8 miles plus 4 feet plus 50 yards. So I know it's written out there, but I'm going to do it anyway. We want all of this in feet. Convert all these to feet. So first off, I'm going to start with 8 miles. So you write what you're starting with first. You put it over 1. I purposely left the bottom of this page blank so we can write all over it. Well, I need to get my miles to feet. So I need to have a conversion factor. So I know that 1 mile equals 5,280 feet. Okay, so where are my miles in my, here, are they on the top or the bottom? They're on the top. So if they're on the top, ask yourself, where do they have to be on the, to cancel? If miles are on the top, they have to be on the bottom to cancel. 1 mile equals what? 5,280 feet. So what I do a lot is I will write down my conversion factors, but I will not keep writing all the fractions they can be because I go miles here, miles on the bottom. So I go 1 mile. Well, 1 mile equals what? 5,280. So that goes up top. And then you cancel that. You multiply this way and this way. But if you have ones on the bottom, it doesn't matter, does it? So this is 42,240 feet. Well, the next one is 50 yards because 4 feet's 4 feet. So I don't have to convert that one. Convert 50 yards. All right. So I'm starting with 50 yards over 1. All right. I know that 1 yard equals 3 feet. So my yards are on top. Where do they have to be to cancel? If yards are on top, they have to be on the bottom to cancel. So 1 yard goes here. And what goes up top then? 3 feet. So yard cancels like that, leaves me with feet. So remember, multiply across the top. So like I said, you just ignore that. So 50 times 3 is 150 feet. And then here you just got 1 times 1. So that equals 1, which doesn't mean anything. All right. So here on the next page, in this example, we have 5 yards plus 2 feet plus 10 inches. Right? Convert all of these to feet. So we just did yards, so I'm not going to worry about that. I'm going to worry about my 10 inches, all right? So I'm going to start with that. Now that I wrote my 10 inches, what do I do next? You put it over 1. Now I need to think of a conversion factor that gets me inches to feet. Well, I know that 1 foot equals 12 inches, okay? So 1 foot over 12 inches, or 1 foot equals 12 inches, not over. Now, if inches are on top, where do inches got to be to cancel? I know it sounds like a broken record, but I promise you, you're going to hear my voice. I don't think I have a good voice for announcing, but sorry, I tried. Inches are on bottom, so that means my 12 goes here. 12 inches are on bottom, what goes up top? Well, 12 inches equals 1 foot. So that goes there, inches cancel. Now we multiply left to right, right? 10 times 1 is 10. 1 times 12 is, just look, block that off. 12. Uh-oh, now what do I got to do? Well, if you get to this, when you do this and this, like that, you just divide. 10 divided by 12 is 0.83 feet. All right. That's why you multiply left to right. You just, oh man, I forgot to delete that. Well, we'll cross it off when we get there. Everyone's favorite thing is to cross stuff off. All right. So the next thing here is a storage tank holds 2,000 cubic feet of water. How many gallons of water will it hold, and how much does that amount of water weigh? Okay, so the very first thing here is we got to write what we're starting with, which we're starting with 2,000 cubic feet of water. We'll just put H2O here. Well, now what? 2,000 cubic feet is over 1. How many gallons of water will it hold? Well, we haven't talked about it yet, but 1 cubic foot of water equals 7.48 gallons. You see how there's no units of water here? It just says 1 cubic foot equals 7.48 gallons. One thing that I want to point out real quick over here. So what a cube is, or cubic is, we can all envision what a cube looks like, right? I'll draw it if we cannot. So this is a cube. A cubic foot means that it's 1 foot this way, 1 foot this way, and 1 foot this way, right? That's what makes it cubic. It's foot times foot times foot makes it 1 cubic foot. So what we're saying in this box of cubic feet, 7.48 gallons fits. So I just want to point out to this real quick. This is a universal constant for all liquids, okay? What I mean by that is if I have a cube and I fill it full of gas, it would be 7.48 gallons. Okay, I dump the gas out. I put motor oil in it. It will be 7.48 gallons. How about mercury? Remember mercury? That nasty stuff that is in thermometers that can cause cancer. If I dumped mercury in this, 7.48 gallons. That's why there is no water associated to this, because regardless of whatever the liquid is in a cube, it's going to be 7.48 gallons. So just FYI, how much it weighs is totally different. Obviously, stuff weighs different, so it's going to weigh more or less, right, per cubic foot. But as far as how much volume, it's universal. Okay, so if cubic feet are on top, where do they have to be to cancel? They have to be on the bottom. Well, how many cubic foot? This is where you need to look at your conversion factor. The only number attached to cubic foot is what? 1. Not 7.48, 1 cubic foot. 1 cubic foot equals 7.48 gallons. That's what goes up top here. So when I do that, I'm going to get 14,960 gallons. And yes, this would be of water because we're talking about water. All right. Well, this is the answer for A, 14,000. Okay, I said we could cross something out and cross that off, and then this one down here, you can, yeah, go like that. We're not rounding to 15,000. It's a whole number, 14,960 gallons, okay? So now that I have 14,960 gallons over 1, just like before, how much amount of water does this weigh? Well, okay, we need to know that 1 gallon of water equals 8.34 pounds. This is for H2O, okay? There are a few numbers out there like 8.35, 8.32, but 8.34 is what we recognize as the average of all of them, okay? And that's what we use in our calculation. So if gallons are on top, where do gallons have to be to cancel? Well, gallons would be down here on the bottom. And up top would be the 8.34 pounds. So gallons cancels like this. 14,960 times by 8.34. Now this one I don't remember off my top of my head. 124,766. Let's see. My calculator would tell me yep, 124,766.4 pounds of H2O. So it doesn't take a lot of water to equal a lot of weight. That's why you have to be cautious when working on dead ends of pipe, especially if you're on a larger pipe. The more pressure and more water it's there, the more pounds you could have acting on it, right? So 14,960 gallons of water times by 8.34 equals 124,766.4 pounds of water. And I'll tell you right now, if this was something I'm paying for, they're overcharging me because they round it, right? All right. Here on the next questions, there's 1, 2, 3, and 4. I'm going to do number 3, and then I'm going to have you all try 1, 2, and 4. Let's see where we're all at. Just to make sure I'm on track for where I'm supposed to be. I am, okay. Okay. So the next part of this is a little bit more complicated than what we've dealt with so far, right? So the very first thing we need to do here is we need to talk about how and what these units are. Okay, so first off, we have like CFS, GPM. Okay, this one we might know. GPM stands for gallons per minute, I hope. Does it make sense? All right, so one of the things that I often see and what people struggle with is how to write these units. These are what we call double units, kind of like miles per hour, gallons per minute, gallons per day, or in this case, cubic feet per second. Okay. So, how do we write these units? That's the thing people are often confused by. How do we write them? So, I'm going to start with, we'll just do well, I'll write it out, but I'm not going to do it. 350 feet. Do you agree with me so far? 350 feet. The P stands for per 1 minute. Wait a second. The per. Let me show you on this one. 9 cubic feet per 1 second. What does the per equal in these? The per equals the fraction bar. So the per, I know there's no per here, but it is. It's there between the per second. Cubic feet per second. It's not written there. Sometimes it's not, sometimes it is, okay? Kind of depends what we're talking about. But because in this, you can see the pers in all of them, right? Except the CFS. So the per equals the fraction bar. So these units are not written like this. The one below it is the other unit. So it's like 9/1 with cubic feet per second, okay? This is the common mistake I see with these. I'm going to tell you right now, if you can do the unit conversions like that and get it right, you're better than I am, all right? I've been doing this for 10.5 years. I do make mistakes, okay? I'm not going to say I'm perfect. By no means am I. So, but this is the most common mistake with doing a double unit conversion is people writing it like this. I'm telling you right now, maybe they're on their call, maybe they're not. Even if they're not, I have had 2 students personally that they could not pass the S1 for, who knows. They took it 3 times. Both of them took it 3 times. And they couldn't pass, right? Well, you know what it was? I finally figured out what they were doing wrong. Happened to be walking over them and looking over their shoulders as they're doing math. And I seen them writing this. Once I broke them of their habit of doing this and writing it right, they got the math. It made more sense. They both passed their exams that time. S1s. S1s, okay, which is not an easy license to acquire. All right. Matter of fact, 2 of my S1 students, I think, are on this call right now. It's not those people, but from what I've seen so far. All right. Convert 9 cubic feet per second to gallons per minute. All right. So, first thing, I wrote down what I started with. Now I need to recognize. So I got to get cubic feet to gallons, which 1 cubic foot equals 7.48 gallons. And I need to get seconds to minutes. Well, I know that 60 seconds equals 1 minute. All right. So with these units, what I choose to do is ignore one of them and convert that one first. So 9 cubic feet. My cubic feet are on top. So where do they got to be to cancel? They have to be on the bottom. So 1 cubic foot equals 7.48 gallons. So if 1 cubic foot's on the bottom, well, it equals 7.48 gallons. So that goes up top. You cancel off your units and you look, I got gallons. Now the next one I'm going to do here, I have seconds on the bottom and then I need to get seconds where to cancel. If my seconds are on the bottom, where do they got to be to cancel? It's on the bottom. It has to be on the top. So how many seconds is this? This would be 60 seconds here. The seconds cancel. 60 seconds equals what? 1 minute. Oh man, can't remember what this one is off the top of my head. 4039.2. All right. 9. So now that I got this, look, I got gallons per minute. My seconds canceled. My cubic feet canceled. Gallons per minute is what I want my answer to be. So I'm there, gallons per minute. So now you just multiply everything across the top. So this is going to be 4,039.2 gallons per minute. So I converted cubic feet per second to gallons per minute. So even though the seconds are here and then they're way over here, they're separated by this, as long as they are on the top and then on the they're on the bottom and on the top, even if separated by another conversion factor, they will still cancel as long as they're in the same series of multiplication. Does that make sense? It's just one's got to be on the bottom, one's got to be on the top. Doesn't matter if they're separated. So that's why when converting this, it didn't matter if I did top or bottom first. I could have very well put 60 seconds over 1 minute here and then put this over there, and it would still give you the same answer. All right. So now with that being said, there's 3 of these, and these are going to be, tickling your brain. I'm going to give everyone like, we're going to say 6 minutes to do these, and then we'll go over them. Okay. We'll see you in 6 minutes. All right, it's been 5 minutes, so let's go ahead and do these, and then we're going to take our like 10-minute planned break. All right. So I guess I know it's been like an hour and a half-ish, something like that, but you all are enjoying it, right? Math at 8:30 in the morning on a Tuesday. So anyway, let's go ahead and do the first one here. And I know, okay, some of you may be lost in this, and that's why we're going to go over this. All right. And this does take practice. That's why you were given this. You can always print it off a blank copy of this and work on that and so on and so forth. All right. Convert 350 feet per minute to feet per second. Okay. I will tell you, we're going to be doing a lot more unit conversions over the next 2 days too. Okay. Unit conversions is a big part of chlorine questions, and it's a big part of fluoridation questions. Right. So, and I will walk through it just like we've done so far. I walk through everything. I don't rush through it. I do it. I don't, and I will actually teach you a couple of shortcuts too. All right. So that's always good news, shortcuts. So convert 350 feet per minute to FPS, which stands for feet per second. All right. So, got feet per minute to feet per second here. So, if you look though, look, I got feet and feet. So do I have to convert my feet? If it's here and here, I do not have to convert it, okay? But I have minutes, and I got to get minutes to seconds. So I know that 1 minute equals 60 seconds. So if minutes are on the bottom, where do my minutes have to be to cancel? Minutes are on the bottom, they have to be on the top to cancel. Well, 1 minute equals what? 1 minute equals 60 seconds. So I'm going to get 50 times 350 times 1 is 350. 1 times 60 on the bottom, like this. This is 60. So this is going to give me 5.83 feet per second. All right, the next one is convert 750 gallons per 1 minute. So if you haven't realized, what I do when I'm writing out the units is I write them as I say them. 750 gallons per 1 minute. All right. Well, I need to get it to gallons per day. Well, so I'm going from minutes to days. So I'm going up in units, so to speak. So if I have 60 minutes, because the next unit after minutes is 1 hour, right? And how many hours are in a day? 24 hours equals 1 day. So these are my conversion factors. You see like the bridge to where I got to go here? So if my minutes are on the bottom, where do they got to be to cancel? Minutes are on the bottom, they have to be up here to cancel. Well, how many would it be? Well, 60 minutes over 1 hour. Now, like if you cancel that, that leaves me with hours on the bottom. And if hours are on the bottom, where do they have to be to cancel? Up top. Well, how many hours would it be? Be 24 hours over 1 day. So you're going to multiply everything this way. And I'm going to get 1,080,000 gallons per day. I'm just double checking. Yep. Okay. All right. There is a one-step conversion of that, but I don't teach it because not everyone knows it. All right. If you know it, that's great. If you don't, that's fine too. Okay. So now the bottom one is I'm starting with 560 gallons per minute. You're going to use these two conversion factors here that we used for this one. So if my gallons are on top, where do my gallons got to be to cancel? Well, I need this conversion factor, so I'm going gallons to cubic feet. So 7.48 gallons here. 1 cubic foot up top. Now, if my minutes are on the bottom, where do they got to be to cancel? Well, minutes are on the bottom, and I'm going to seconds. So this would be 1 minute. And then 1 minute equals 60 seconds. So now you multiply everything this way and everything this way. I'm going to get 560 over 448.8. And I do that, I'm going to get a number. I think it's like 1.247, blah, 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 blah. But we round up to 1.25 cubic feet per second. So these double ones are a little bit harder. The fact that they involve multiple steps, but remember, like we talked about, minute here, minute there, as long as it's on top and bottom, they still cancel and equal out. These are something that take practice. Okay. I don't expect anyone to be perfect at these. I mess them up. I've been doing them for 10 years. So, all right. With that being said, let's go ahead and take a 10-minute break. So we'll be back here at 10:03 for your next poll question also. All right. We'll see you all soon. Hello, everyone. We should be getting back now. I do believe the poll question is running. That we have been through our time, 10 minutes here. Allow for a couple more minutes for people to complete the poll. I think, Jim, are you back?
Yep, here's Scott.
Okay. Yeah, let the poll question, run for like another minute, and then we'll go ahead and get moving with class. We're doing pretty good. I'm about dead on time as usual, so. Maybe some of you will find this comical. This is Michigan's, the annual meeting of new residents is this weekend. Today is a pretty good day for that, especially since we're getting snow and it's sort of wet and, might be a little bit slushy. So if any of you are traveling today, do take it easy. I would be interested to know too. I was looking at some of the poll things there, and it looked like a couple people said they have five or more. I'd be interested to know what cities those are, just out of curiosity. If they want to write that in the QA, just because I'm just kind of curious. Do I still need to do? John, the answer to that is yes. Well, okay. Are you? I guess let me rephrase that. So if you're doing the CECs, like the ones you need are from this class, and you need to renew by the 15th, that is a yes. So like if this will cover your CECs, yes, you do need to do a form. But if say this is like the first part of the CECs you need, and then you still need more, so you'll be doing classes, I don't know, 2 weeks from now or join Expo or whatever the story is, only send your renewal application when you have enough CECs to renew, okay? I do have to make it note that with the CECs, after the 15th of this month, depending on what level license you have, adds additional CEC requirements. There's a 1-year grace period. So every 3 months, more CECs will be required for you to renew your license, just FYI, okay? And if you are in charge of a water system, be it non-community or community, if you go past the 15th, your system is in violation, okay? Without having a certified operator, because technically, even though there's a grace period, you are no longer, quote, certified when it comes after the 15th, okay? So if you're just a normal operator, you're not the OIC, and you're just getting your CECs between now and March, that's fine. Just renew once you have enough CECs on record. So some places, like if you do some online trainings, won't send a list to us. So you have to send your certificates of completion either in or with your renewal application, okay? Like Jim and his group, they will send us a after report roster, and we will enter them to your record. So look at your record on our website. If you do happen to see that it's on there, you do not have to send us a certificate of completion to show us you took it. We obviously gave you credit for it, okay? So I hope that answers that question. Yeah, that's something that you wouldn't have been able to do, Jim. Highland treatment has 20. Wow. Thanks. It's been a while since I've talked to the Dawsons out there. 20+ people. All right. Well, good. Let's go ahead and continue with what we were doing. Did you stop the poll? I'm assuming by now, right, Jim?
Yep, it's off
Okay.
now.
All right.
Go ahead.
So let's go ahead and move forward with that. Hopefully the 20+ people are finding something. Real quick, before I move on into this, there's something I want to talk about. So hopefully you got like a little area or piece of scratch paper here real quick? I do, but I'm hoping you do. There's something I want to talk about real quick that I just realized that I need to put into this thing. It's not in here. It's talking about the order of operations, okay? Order of operations. Okay, I know. This is something you're probably like, oh, I got it. I remember learning, please excuse my dear Aunt Sally, right? So, a lot of people remember, please excuse my dear Aunt Sally. That's what they remember for this. So, let me try to remember here. Yeah, okay. So, let me write you a question. I want you all to do it on your own, okay? All right, I want you all to do this on your own. So the place that's got 20 plus people at Highland, don't cheat, all right? Don't work together on this. Try it on your own there, all right? So 810 divided by 8 times 6, all right? I want you to tell me what the answer to this is based on the order of operations from what you remember, okay? And we will see what we get. So I'll give you like a minute to try this, right? Okay, so how many people got this as an answer? They did 16.875. So Amy got it, I'm assuming. All right. So I hate to tell you this, but this is wrong. Okay. And let me explain why. Everyone, a lot of us either remember PEMDAS, please excuse my dear Aunt Sally. Some of us go, man, it's been so long, I don't remember. That's fine. That's why I'm teaching order of operations, because this is how math is supposed to be done. Okay. So we have 810 divided by 8 times by 6 here. And according to please excuse my dear Aunt Sally, this is parentheses, right? This is exponents, this is multiply, this is divide, this is add, this is subtract. Does that make sense? Well, according to this and what most people think when please excuse my dear Aunt Sally, well, my dear means multiply first, so this should be 48, right? Well, that's not right, because the true answer to this question here is 607.5, I think, is what the true answer is. Yeah, so the true answer is 607.5. So let me explain how this works, okay? So first off, just to prove my point, we probably all agree that the guy who made this calculator, or the engineer, whoever it was, is probably smarter than, me, definitely richer than me, right? And any of all of us probably. So 607.5 here. So what you actually do with order of operations, this is where people get confused, is they think of it as please excuse my dear Aunt Sally. And the thing that's wrong with please excuse my dear Aunt Sally is the fact that it doesn't take into account the degrees of math. There's the first, the second, and the third degree of math. So the first degree is just like it, parentheses, exponents, which refers to like a square, and square root. Square root is actually one of the very first things you do too. You have to square root something. The next would be multiply and divide. And the other is add and subtract. Okay, so these are levels or degrees of math. You do parentheses first, exponents first, square roots first. Second, you multiply and divide. And third, you add subtract. But when you're on the same level, this is what's the true how math works. When on the same level, it is left to right. just like reading a book. All right. That's what everyone gets wrong. So if you look 8, 10 divided by 8, multiplied by 6, are these the same level of math? They are. They're not like, my dear. So if you were taught to do it that way, it means you didn't have a very good math teacher who taught you the proper way, which would be 8, 10 divided by 8 first, because it's left to right, which is going to give me 101.25, I think, right? 8, 10 divided by 8. Yeah. So 101.25, and then multiply it by 6, which is where you get to 607.5. So next time you're on the Facebook and you see those math things, try it. And then argue with the people and tell them how dumb they are, okay? Because that's what I get in a lot of arguments on there about math, because it's astonishing how many people were never taught the proper order of operations. And I'm not taking this as a dig at anybody, because I see it across the board. I have been a math teacher for 10 years now for the state, almost 10 and a half now, because I'm coming up on 11 years. And I have seen this time and time again. Doesn't matter if the people are young or old. I've seen a couple 18-year-olds just this last fall in that boat. They didn't know how to do order of operations. They weren't taught right. So this is how the true order of operations works, okay? So I want to go over that real quick before we move into areas and volumes, because areas and volumes are pretty straightforward. Most people, to be honest with you, this is easier than unit conversions we were just doing. Unit conversions is involved in areas and volumes, but I will say this is easier. All right, so anyway, with a rectangle, the area, or something to first realize is start thinking about areas. So let's look at the units first. What do these all seem to have in common? Well, the one thing I see is they all have a 2 on them, right? So if we take like feet squared by chance, that's the same as saying feet times feet. Does that make sense? The square means times itself twice, okay? So feet times feet gives you feet squared. All right, with that, the area, the very first thing we're going to look at is a rectangle, okay? I'm going to just tell you, I'm not going to waste your time with learning like, oh, the area of a triangle or the volume of a, pyramid or whatever. I'm going to teach you what you need to know, nothing else. The area of a rectangle is the length, which would be typically in feet, and the width, which is typically also in feet, okay? So calculate the area of the given room in the dimensions. So the length is 34 feet times by 22 feet. Well, when I multiply those out, I'm going to get 748 square feet. Because we had feet times feet like this, that's where we get the 748 feet squared. All right. So the area of a rectangle is pretty straightforward. Now, I know it's not on here, but let me ask you I'm going to try to draw a perfect square, but I'm not promising anything. All right, pretty close. So the area of a square is a little bit different than the area of a rectangle, but my guess is if I tell you, you could figure it out. If I tell you that this side is 15 feet and ask you what the area is, I'll give you like 30 seconds to figure it out. That's not 16, that's a 15. There, it looks better, 15 feet. If I told you one side of a square is 15 feet, what's the area? My guess is you're going to get it. No problems. It's going to be 225 square feet. Because the area of a square and area of a rectangle are pretty much the same thing. The shape is a little bit different because on a square, if one side's 15, the other side is also 15, right? So 15 times 15 gives me 225 square feet. All right, the area of a circle is up next. Well, I want to point something out here real quick. So the area of a circle, there are numerous different formulas for the area of a circle, right? One that some people, and if there's any engineers in the room, I know this is you, pi times 2 pi r, boy, getting confused here. Radius times r squared, pi r squared. All right, is the area of a circle. That's what some people like. But the thing about it is, how often in the water industry do we run into this word? R stands for radius, which is half of the diameter, right? You know, I can't say I've ever replaced a water main or anything, but I can tell you that I have never heard of a water main referenced as a radius. Just saying, it's always been diameter. So the formula that I choose to use is going to be 0.785 times diameter times diameter. I write it out. I don't rely on myself to remember to hit this button right here. See this little button right here? That's how you square stuff. But I'm telling you, it's going to be hard. So when I type stuff out, will just type let's say it's 4 feet by 4 feet, right? Something like that. I write it all out in my calculator. So the other thing that I often get asked is, where does the 0.785 come from? Well, if you have any younger kids, you will know that when they're playing with their blocks, the round peg will always fit into the square hole, but the square one won't go in the round hole. Okay. So if you're privy to this information, maybe you've dug up some old water main. And when you dig up the old water main, the old wooden water main, I've seen old wood square water main that has beveled ends to fit together, right? So this circle fits inside this square, but what percentage does it take up? Because if you look, there's still some not filled in space here, isn't there? So what percent of it? Well, if you were to say 78.5%, you would be correct. So that's what the 0.785 comes from. There is a mathematical way of solving for 0.785. I didn't put that in here, but there is a mathematical way. If you want to see it, I can send it to you in an email. All right, so this question is saying, what is the area of a circle that has a diameter of 20 inches? All right, well, the diameter of 20 inches means that 0.785 times 20 times 20, when I do that, it gives me 314 inches squared. And to prove my point, pi times radius squared, right? Well, the radius is half the diameter. That you do need to know. Diameter means 2r. It's half of it. So it takes 2 times to get the radius. Let me show you. So the radius of 20 would be 10, right? So pi times 10 squared. Oops. What the crap? 100. Because 10 squared, well, pi is 3.14 times the radius, 314 square inches. So even doing pi times r squared still gets you 314 inches squared. You get the same answer. So I will always, and moving forward, use diameter. 0.785 times diameter squared, okay? So the next thing we're going to talk about is finding the volumes of stuff, all right? And you're going to find out that there is a quick relationship between the two of these. So the first thing to think about is we got what do all these units seem to have in common? They all seem to have the 3 in common. So like cubic feet means feet times feet times feet. Cubic means feet times itself 3 times. That's how you get cubic. So now we're going to first talk about a rectangular prism. Well, I hate big fancy words. All right, rectangular prism. Well, if you think about it, does this not look like a, we'll put the Amazon thing here. We'll do that half smile thing or whatever. Does it not look like a box to you? Sure looks like a box to me, right? It even says Amazon on the side, you know? So the thing about it is a rectangular prism is a box. The room that you're most likely sitting in is a rectangular prism, right? If it's got square walls, it's a rectangular prism. All right. So the very first thing with thinking about the volume of this is look at this first off. Length times width was also the area for or crap, I gave it away, was the formula for area. So all we're doing is we're taking our area formula for a rectangle and adding a third measurement to it. All right. Multiplying by a third measurement, which in this case would be the height. Because length times width was the area, but we had the height, and that gives it the third dimension, so to speak, right? Something like this. So it makes it a three-dimensional object. So here we're saying determine the volume of it given the length of 34 feet, the width of 14 feet, and the height of 11. Okay, so when we do that, we're going to get 34 times 14 times 11, which gives me 5,236 cubic feet. Now, one thing to keep in mind, this word height here can be numerous names. It can be high, it could be height, it could also be tall, and how about depth? Because if we're talking about the depth of a filter, depth of a basin, you could be saying the depth. That's the same word, just it's the same meaning, just different words, okay? So that's one thing to keep in mind, that you're not always going to see height. It'll say high, tall, and depth sometimes are common words that we use for this third measurement. Okay. And if you're reading a question and the question has 1, 2, 3 measurements in it, that usually means it's a box. Okay. You're dealing with a box. Next thing I want to talk about is the volume of a cylinder. Well, the volume of a cylinder, if you look here, what does this look like? This looks like the area of a circle to me. And all we did was we added the height here to it, right? All right, so it's the area of a circle. And here we're talking about the height. Well, just like in the fashion with the rectangular prism or the box, just so you know, I call that a box and I usually call this a pipe because it could be a pipe, right? But anyway, height can also be referred to as high, height, tall, depth. Yeah, okay, well, those are all the same. Oh, but what about long, length, stretch, and run? What? Why would it be those? Oh, I got 1,000-foot, 12-inch pipe. Well, that 1,000 is referring to a horizontal length, isn't it? It's 1,000 foot long and it's 12 inches in diameter. Right. So these are for vertical, a barrel, storage tank, something like that. These are horizontal terms. Your system is full of cylinders, isn't it? When you start to think about it, it's like, oh man, yeah, you're right. There's pipes everywhere. Pipes in the system, pipes in the plant, pipes in the well itself, right? There's a lot of cylinders or pipes. So how we're going to do this one. All right. So first off, a chemical solution barrel is 4 feet high, has a diameter of 3 feet. How many gallons of solution will this barrel hold? Okay. So my formula is 0.785 times diameter times diameter, and it says it's 4 feet high, so times 4 feet. So this is going to give me 0.785 times 3 times 3 times 4 gives me 28.26 cubic feet. Well, that's cool. And we can cross this part off right here. We like crossing things off. And then we'll cross, we'll just cross all that off too there at the bottom, all right? And the reason for that is I do not like that rounding was done by not me. How about that? Let's put it that way. I'm a chemist and biologist. I'm not that E word starts with engineer. All right. So I don't like rounding off the whole numbers. I like to leave it, as most accurate as we can. All right. So the very first thing, okay, we got 28.26 cubic feet, but this asks for how many gallons a solution will hold. So let's go ahead and do this the traditional way. I got 28.26 cubic feet over 1. Well, I know that 1 cubic foot equals 7.48 gallons, right? So my cubic feet are on the bottom. They got to be on the bottom to cancel. So 1 cubic foot equals, that's what goes here, 7.48 gallons, right? So 28.26 cubic feet times by 7.48 is going to give us 211.38 38 gallons. Oh, well, that was cool, but that required 2 steps. So first off, let me get the unit conversion sheet over here real quick. I want to show you something. So 1 cubic foot equals, there, I'll put it right there. 1 cubic foot equals 7.4 gallons. Okay, so that's saying, remember the cube I drew? Right, that this is 7.48 gallons. If I have, let's say, 2 of those cubes, they're both a cubic foot. How many gallons do I have then? Well, you're just going 2 times 7.48, right? No. 14.96 gallons. So all you're doing is you're taking your cubic feet and multiplying by 7.48, correct? So if I had 3 cubic feet, what would you do? Times 7.48. 22.94, I think, something like that. But you get my point. What I'm getting at here is if you have cubic feet, oops, forgot the cubic, all you do is multiply by 7.48, correct? All right, so let me go back to this question now. If I write this out as 0.785 times 3 times 3 times 4, what are my units going to be here at the end of this? I'm going to be at cubic foot, correct? That's what we got. Well, how do we get cubic feet to gallons? We multiply by 7.48, and that will convert it to gallons. So what I'm saying is if the question asks for how many gallons right off the bat, because that's one question, I can do it in one step by using my volume formula. Timesing it by 7.48. And look at that, you get the same answer. So this is one of the first shortcuts I'm going to start to show you. When volumes, if the question's asking you for gallons up front, well, you can do it because you got to find the volume of it anyway. You can then put it in the conversion factors and auto convert it to gallons, just like that in one step. So then that makes it, look, I got the same answer. It's not like I changed anything. And, I often get asked, does it matter what order you put it into the calculator? It does not. With multiplication, you could put 7.4 first, but the problem is you got to remember to do that. That's why I always start volume, diameter, height, and then my conversion factor to get it to gallons, okay? We're going to be using that shortcut tomorrow quite a bit in chlorination. Okay, here we go. Here is 3 questions. I'm going to give you all, we'll say 5 minutes to do these on your own, and then we'll go over them. And we only got a couple more pages and we're done, all right? All right, let's go ahead and go over these. All right, what is the area of a rectangular room that measures 32 feet by 42 feet? So 32 times 42. 1344 square feet. All right, the standard isolation area of a municipal well is 200 feet in all directions from the well. How many square feet is this? So the thing to keep in mind is 200 feet. So it's 200 this way. It's also going to be 200 feet this way, which means the diameter is what? 400. I know, this is a trick question. So the area is going to equal 0.785 times 400 times 400. There's 125,600 square feet. And I also want to teach you something else while I have the opportunity to. The standard isolation area of the municipal well is 200 feet in all directions from any source of contamination. Keyword here is any source. This is a Safe Drinking Water Act question. Standard isolation area of a municipal well is 200 feet from any source of contamination. You can take that to the bank. I promise you that is not a lie. But how about from major source? Any idea how many feet that would be from a major source of contamination? How about 2,000 feet? And then from a minor source, keyword being minor here, how many feet would it be from that? So for major source of contamination, which is like a dump or a chemical factory or a chemical spill, underground leaking storage tank, right? Something like that, a giant animal farm. All right. A minor source is 200 feet. Any and minor are the same. Major is 2,000. Okay. Don't say I didn't teach you something else here today. What is the volume of a cylinder? It's 15 feet high, has a diameter of 9 feet. Give me it in cubic feet and in gallons. Okay. So first off, I know the volume is 0.785 times my diameter times my height. And since I need the answer in cubic feet and gallons, I'm not going to shortcut this. I got to do it twice anyway. So this gives me 953.78 cubic feet. Well, cubic feet are up top. Cubic feet got to be on the bottom. 7.48 gallons up top to get it there. So 7,134.27 gallons. All right. You know, actually, I think I lied. I'm pretty sure. Is there another? There is one more question on the next page. I forgot to tell you to do. So why doesn't everyone? I'll put that there for a second so you can copy down. Everyone take like 2 minutes to do page 14, number 4 on the top there. We'll go over that last poll question, then we're done. All right, I promise. So go ahead, everyone, try the number 14 on the next page, and then we'll go over it, and then we'll be done. All right. Number 14. So this brings in a concept that yet we have yet to talk about, but I'm going to teach you. How many gallons of water will a water main hold that is 18 inches in diameter and 1,500 feet long? All right. So the very first thing you need to do is you actually need to convert your inches to feet, right? So always, excuse me, convert inches to feet. And all you do is you divide by 12. Okay. Because if you put these two different units into the formula, you're going to get a very different answer. Okay. And being that you're converting to gallons, your answer has to be in cubic feet. So you're going to divide the 18 by 12, which is going to give you 1.5 feet. All right. And then you're going to take your volume, which is going to be 0.785 times my diameter of 1.5 times 1.5 times 1,500 feet. I mean, these are all feet. Well, I need it in gallons. And if you have cubic feet, how do you get cubic feet to gallons? Well, you multiply by 7.48. Okay. I'll give you a minute real quick to do that because of the fact that it had the inches in there. Maybe some of you did it as 18 and your number's way off. So go ahead and take a second to do that. Oh, 19,817.33 gallons.